Right. Here we are. My name is Dustin Hartnett, ENME351, Lab 6. Start off with a quick demonstration. So the servo here starts at 90 degrees. It's going to come down, hit 0, keep going. It's a little jumpy. Goes down to -90, and then reverse. We can bring it all the way back up to 90. So a little jumpy, but from -90 to 90. The circuit here is a potentiometer hooked up with ground and power, which is 5 volts, and the ground port on the Arduino Uno. This A0 is connected to the middle tongue of the potentiometer, reading its value from 0 to 1023. And then on the back side here, we have the servo motor attached to the same power and ground as the potentiometer, and then hooked up through this white wire to analog pin A0, which powers and controls the servo. Swing over here to our serial monitor. As we are running through our start at 90, comes all the way down, 0 to -90. The bottom is jumpy, comes back up, hits 0, all the way through to 90 degrees. So on the left, we're reading our potentiometer value from 0 to 1023, and on the middle, we are getting our T control from 500 microseconds to 2500 microseconds. And on the right column, we are getting our degrees from -90 to 90. Now the code here starts off initializing some values. The period is 20,000 microseconds. The T low and T high for the controls, -90 degrees and 90 degrees, are 500 and 2500 microseconds. The spec sheet had it at 1000 and 2000 microseconds. However, that was only getting me about 45 degrees on each side, so about 90 degrees of rotation. So I had to mess around with the numbers a little bit, and then it ended up with these giving me a full 180 degrees rotation. In our setup, we're just initializing pin 3, digital as an output pin, and analog 0 as input. Down to the loop. So the potentiometer value is analog read A0, which is connected to the potentiometer. And then I used mapping functions to calculate my time control values based off the potentiometer function. I then took that time control value and turned it into a degree value from -90 to 90 using that same function. I then printed them out to the serial monitor, and then below that we digital write the pin for the servo to high for the time of the time control. Then we write that to low for the integer value of the period minus the time control to finish out that period length. And there we have it. That's the whole shebang. Join us next week. Thank you very much.